Hello, math students. Today is day one. This is a second video. It's now on completing the square, which is a necessary operation so that we can put our equations in standard form. So what happens a lot of times is you'll see an equation that has a squared in it or a squared term in it, and you'll want to be able to put it in standard form so you'll know exactly where your conic section is located. So the first equation we see here, hopefully you can identify that this section is going to be a parabola because there's only one squared term in it. So we know it's going to be a parabolic shape, and our goal will be to get it into a form of y equals some form of x minus a number squared plus another number, because that would be a parabola that's been moved a certain way. And the only way we can get it that way is by completing the square. So the first thing we need to do is we need to have a positive coefficient. So I'm going to change every term by dividing by -1. I'm going to have x squared minus 10x minus y plus 21 equals 0. I'm going to collect all of the terms that will help me make a square term. So anything with an x in it, I'm going to leave over on the left side, and I'm going to move the y over to the right. I'm going to put 21 over to the right, and I'm going to just play around with x squared minus 10x. So basically I'm doing what's called, I'm clearing out the equation so I can make room to pick this perfect number to make this a perfect square trinomial. And the way that you find that perfect number is you look at the middle number that would be in the trinomial. It's -10. So what I want to do is I want to take half, it's just a simple algorithm. To get a perfect square trinomial, I need to take half of the middle number, and I'm going to need to square it. So I make that perfect square amount. So some people think that I'm basically adding -5 to it, but essentially I'm adding -5 quantity squared to the right, to the left side. So as a result, I have to add the same amount that I added to the left side. I have to add to the right side to keep everything equal. So on the right side, I'm going to add that same -5 that's squared. So remember, -5 squared is 25. I'm adding 25 to both sides. So on this side, I'm going to have x squared minus 10x plus 25. And on this side, I'm going to have y minus 21 plus 25. And remember, the squared takes care of that negative, so that's why it's plus 25. Now on this side, this is a perfect square trinomial. So this is x squared, this is x minus 5 20 squared equals y plus 4. Now I'm ready to finish solving this equation. I solve it for y. Y is equal to x minus 5 squared minus 4. Now this is an equation of a parabola that I know is moving, I know it's going to be located at 5 to the right because I'm looking at my transformation. I'm going to be at 5 to the right, and I'm going to be down 4. So my vertex is going to be at -5, comma, -4. And the parabola is going to point upward. In the next example, we have what looks like is going to be a sideways parabola. The reason I know that is because I only have a y squared term. So, and I also have a leading coefficient. This means that we're going to have a little bit more math work to do. So let's clear everything out. I'm going to move the 49 over to the other side. I'm going to move the x over to the other side as -x. I'm going to just have -2y squared minus 20y. Now, I don't like working with leading coefficients that are negative. So all I have to do to get rid of them is I'm just going to divide everything by -1. So I really have 2y squared plus 20y, because I'm dividing by -1, equals x minus 49. Remember, everything gets moved on over. So the next thing I'm going to do is I've got to factor out that leading coefficient because I don't like to complete the square with leading coefficient. So I'm going to factor 2 out. I've got y squared plus 10y plus what's going to be my perfect number for that perfect square equals x minus 49. What I'm going to do at this point is I need to figure out, just like I did before, what that perfect number is. And it's 10 divided by 2, and I'm going to square it. So remember, the recipe for this is you take that middle coefficient, divide it by 2, you're going to square it. And I always put it in as a good habit as being like 5 squared. Just remind me that that was 5. Now, remember, I added 25 to the left inside of a term that's being multiplied by 2. So really, I multiplied, or I added 50 to the left. So on this side, I've got to add 50 just to keep things balanced. I'm going to rewrite this in its perfect squared trinomial form. I have plus 10y plus 25 inside the parentheses equals x plus 1. So I'm just going to simplify those terms. I'm going to now write this as just a binomial squared using, because I did make a perfect squared trinomial, so it's y plus 5 squared equals x plus 1. And now I'm solving for x. So I end up getting 2 times y plus 5 squared minus 1. And that is an equation of a sideways parabola. So that's equation number 2 finished. And if you have Desmos, you can plot that for sure on Desmos to see that it's a sideways parabola opening to the right. The last one we have to do is completing the square. And in this case, we have 2 square terms. So I'm either anticipating it to be an ellipse, a circle, or a hyperbola. In doing this one, I have to separate the y terms from the x terms. So I'm going to keep everything on one side. I have x squared plus 6x. And then I'm going to have y squared minus 2y. And on the other side, I'm going to subtract 9. Now, when I have x squared plus 6x, I go through the algorithm and I'm going to like say I've got 6 divided by 2. I'm going to square that. So my perfect number here is going to be 3 squared. If I add 3 squared here, I've got to add 3 squared to both sides. So there's 3 squared. Plus y squared minus 2y. So there's a perfect number to put here, which should be take negative 2 divided by 2 and square it. That'll be my perfect number. So this will be negative 1 squared. So if I'm going to add, that's basically 1 I'm adding. So over here, I'm going to add 1 also. So now when I simplify this, I have x squared plus 6x plus 9 plus y squared minus 2y plus 1 equals, these cancel. It's negative 9 plus 9, and then I'm left with 1. So what I end up getting is I have x plus 3 quantity squared plus y, and that's minus 1 quantity squared equals 1. And this happens to be a circle that has just been, because it's a general circle equation, that's just been moved. Its center is at negative 3 comma 1, and the radius is equal to 1. And you can plot that on Desmos just to verify it. You can either plot this equation or you can plot the circle equation in standard form. I hope this review of completing the squares helped you understand why we use it to figure out what our conic equations are in standard form. And I look forward to hearing your comments in class tomorrow, or if you can just write them on the comment area of the video, that would be great. Thank you. Have a good day.